Next, AC circuit containing only on inductor. Inductor is nothing but a coil. So here consider the inductor of inductance L. It is connected to the alternating voltage source. Alternating voltage source is Vc equal to Vm sin omega t. This is applied voltage. Because of this voltage in the inductor, it induces the self-induced EMF or back EMF. Already we studied self-induction. Self-induction means when we apply the voltage to the coil, in the coil it produces a EMF. The producing EMF is opposing the applied voltage. So there is a back EMF E is equal to minus L into di by dt. Minus L into di by dt. By the applying of Kirchhoff loop rule to the inductive circuit, we can write V plus E is equal to 0. That means induced EMF in the coil is equal to minus Ln di by dt. V is the applied voltage V minus of E is equal to 0. It can be write V plus E is equal to 0. We can write V is equal to minus E. Now substitute the value of V and E. Applied voltage is Vm sin omega t. Induced EMF is equal to L into di by dt. We need of current. So from this di is equal to Vm m by L into sin omega t into dt. Take integration on both the sides. So integral of di is equal to integral of Vm by L into sin omega t into dt. Take it out the constant value Vm by L. Vm by L in integral of sin omega t into dt. Integral of sin omega t is nothing but a minus cos omega t. For the integration, we put only constant. So plus constant. So cos omega t, change it to the sin omega t by this formula. So cos omega t is equal to sin pi by 2 minus theta minus omega t. Cos omega t is equal to sin pi by 2 minus omega t. It can be right minus sin pi by 2 minus omega t is equal to sin omega t minus pi by 2. So we can write instead of cos omega t, I is equal to Vm by omega L into sin omega t minus pi by 2. This Vm by L, that means V by R. Omega L is considered as the resistance R. So V by R, it is nothing but a Im, maximum current. I is equal to Im sin omega t minus pi by 2. So Im is equal to Vm by omega L. This is for the inductor circuit. Already we studied the resistor circuit. Im is equal to Vm by R. Vm by R. So this R is nothing but a resistance in the resistance circuit. In the case of inductor circuit, resistance is the omega L. Resistance is the omega L. So in the inductive circuit, in the inductive reactance is XL is equal to omega L. XL is equal to omega L. We know the omega angular frequency is equal to 2 pi f. So XL is equal to 2 pi f into L. 2 pi f into L. This is the inductive reactance XL. Inductive reactance XL. Next for the Phasor diagram. So in the Phasor diagram, the applied voltage is OA, the current is OB, with the reference axis, the applied voltage makes angle omega t, angle between the OA and OB is the pi by 2. That means angle difference between the voltage and current. This instantaneous voltage Vm sin omega t. This is instantaneous current Im sin omega t minus pi by 2. That means current will be lagging the voltage of minus pi by 2. Current is lagging the voltage of minus pi by 2. Okay. With the angle pi, this is a pi by 2. So voltage is leading the current with the angle of pi by 2. Otherwise we can say current is lagging the value of pi by 2 with the voltage. For the waveform diagram, this is a waveform diagram. This applied voltage V. This is a instantaneous current I. The current will be lagging with the angle of pi by 2. Okay. With the angle of pi by 2. So for the steady current means for the DC current there is no frequency. So frequency will be 0. In this case, inductive reactance XL will be 0. In the case of ideal inductor, it have no resistance to the DC circuit. It has no resistance to the DC circuit. Because of in the DC circuit, the frequency will be 0. Okay. That's all about the AC with the inductor. So in the main thing will be in the AC with the inductor coil, current will be lagging the voltage with the angle of pi by 2, or voltage is leading the angle of pi by 2 with the current I. That's all about the AC with the AC with the inductor.